So dear participants, welcome back with our discussions on hardware aspects of PLC. Let us see what is a memory unit. The basic function of this unit is to store the program that contain the control actions to be exercised by the microprocessor. And another purpose of the memory unit is to store data from the input for processing, and that is there for the output also. So it stores the data from the input for processing and data ready for the output, for controlling purpose. So mainly to store the program and store the data. It is the basic operation of a memory unit in a PLC. Then you have got this communication interface. They are used to receive and transmit data on communication networks from or to other PLCs or IO units which are there in remote locations. Now this communication interface, as I have already told, is very critical aspect while talking about PLC, and therefore in your master's syllabus we have kept a complete different subject on the communications, that is industrial networking. Now this communication interface are concerned with actions such as device verification, because whenever you are having many devices in a particular network, then verification of the particular device with which you want to communicate is very important. Then you have to have synchronization between the user, the application, and across the devices. You need to acquire data from one or many devices, and you need to manage all these things properly. You need to send data to the proper device. So all these things need proper management, and therefore this communications is one of the most important aspect whenever we are talking of PLCs. Because please don't think, this is I am repeating time and again, that PLCs are not just stand-alone units in the factory atmosphere, as in comparison to the atmosphere that you are receiving in your lab. In your lab actually you are applying the PLC for one application. You are putting some switch on, switch off, and you are getting some lights on or lights off, where only one PLC is playing the game. But in industry there are several, maybe hundreds of PLCs in network, and under such circumstances, in order to get one PLC from that network, then program that PLC to communicate with that PLC to get that data from that PLC, this is a mammoth task that has to be understood by you right at this level, in order to just feel that what big spectrum of applications this PLC can have and what is its capacity. So you can see here, this is a supervisory system. Supervisory system means that is the central supervisory system of your, maybe the in industry, that may be a SCADA system, and ERP enterprise resource planning, which is nowadays installed across every big industry. You have got a common communication network bus to which the PLCs are connected. These PLCs are finally connected to the machine or the some plant operation. So these PLCs, they are not directly connected to one system. They are connected to the communication network bus, and this communication network bus is finally connected to the supervisory system. This is a very simple and basic block diagram of the communication model that I have shown. The communication is far more complex a thing that you need to understand. Now comes the input output unit. The input output unit are the most important unit on which we will concentrate a lot, because this is where the processor receives information from external devices and communicates information to external devices. So input and output unit are just like ports of a country. In microcontroller, if you have already come across some course on microprocessors or controllers, you are versed with the terminology port, input port, output port. Why they are called port? Because port is that part. If you think about India, there is Mumbai port, Gujarat port, Calcutta port, Madras port. Because through these ports, or even you can talk of airports also, through these ports we are actually getting passenger or material from other country, or we are sending other country or other places, or we are sending this our passengers or material to other countries or other places. So now you see that in the case of a PLC, which are other things, the other things are the external devices from which it is getting some signal or data, and the other things, the other external things to which we are sending some signal or data. So therefore, when such things are connected, they are connected to the input output unit only. And each of the terminals of the PLC that are under this input output unit are called those input terminals or output terminals. Now you see, the inputs might be from switches or other sensors. What can be the sensors? They can be the proximity sensors, photoelectric cell, temperature sensors, flow sensors, level sensors, plethora of sensors are there. And then the outputs might be to conductors, motor starter coil, solenoid valve, relays or other similar things. We will have a detailed discussion on that in our later course of lecture. Now you see, whenever we are talking of these input and output devices, they can be classified as the signal they give actually. Now these signals can be of three types. One is a discrete signal, other is a digital signal, and third one is the analog signal. The devices that give discrete signals, you can see here, I will go to a figure. This you can see, this is a discrete signal, either completely on or completely off. Then here are the digital signal. This is the digital signal. We are having digital pulses. And this is an analog signal which is continuously varying with time. So now see, devices that are giving discrete signals are the ones where the signals are either on or off. We can talk of simply a switch. A switch can be either on or can be either off. So this is a particular example in which we can find that how discrete signals can be there as the input to a PLC. Now you see that incremental encoder. If I talk of an incremental encoder that generates a regular pulse string, if we put such device as an input device to the PLC, that will be considered as a digital device because we are having continuous on-off signal. Now you see, analog devices are those devices where signals is having size that is proportional to the size of the variable being monitored. Now you see, this is a completely new definition. You can see the signal is voltage, right? The signal is voltage. Signals whose size is proportional to the size of the variable being monitored. Now when temperature is being monitored, the signal is there, the signal is continuously changing according to the size of the parameter. So therefore we can easily think that how the analog device is working, where there is a physical parameter changing, and when the physical parameter changes, accordingly the signal changes. So therefore this is the purpose of an analog device. Example we have given that of a temperature sensor whose output is a voltage, and the voltage is proportional to the temperature that the sensor is sensing. So these are the three types. One is the discrete type, other is the digital type, and third one is the analog type. These three types of inputs we can give to a PLC, or these three are the types of outputs which we can get from a PLC. Now let us have more detail on input output unit. Now you see that it is the input output units only through which programs are entered from a program panel. Now this is a bit confusing to you, because if you have got some earlier experience with working with a PLC, you will definitely ask me that we are never entering the program through some of the input terminal or some of the output terminal. Then how are you able to say that we are entering the program through this input output unit? No, actually the input output unit, in that sense that it is communicating with the external world, in that sense we can say that input output unit, through input output unit you are actually putting the programs inside that. Whenever you are putting some cable, Ethernet cable for programming the unit, then programming the PLC rather, then actually the programming signals that are going through inside the PC, inside the CPU of the PLC, that is going through some part of the input output unit only. You are not employing any input terminal or output terminal for programming the PLC. This is very sure. Now you know that whenever we are trying to access any input terminal or any output terminal, then we must know that that particular terminal should have an address, and that should have an unique address. One terminal should not have the address of other terminal, otherwise your entire process will be under tremendous problem. This is just like a road. Okay, suppose you have gone to a particular housing society where there are several row houses on a certain lane, and you can number the house. Okay, you can number the house 1 2 3 4 5 6 like that. You can think the same for a PLC, either input side or output side. You can think the input side as one lane and output side as other lane, and in this lane there are terminals, input terminals, and on the output lane there are output terminals. Just like the houses that were having some numbers in accordance to the length of the lane, that once you start walking through the lane you come across house number 1, then house number 2, then house number 3, house number 4, like that. In the same fashion, here also on the input side you can have input terminal 1, input terminal 2, input terminal 3. Under the output side you can have output terminal 1, 2, 3, like that. Now be very sure that each and every manufacturer of PLC, I am talking about the giant manufacturers like Siemens, Allen Bradley, it can be Mitsubishi, it can be Toshiba, it can be Omron, it can be Schneider, anybody. They are having their own way of numbering the PLCs, and that you need to know. This makes the programming of PLC a bit more complex, because whenever we are trying to program a PLC, then the style of program that we are maintaining for maybe Siemens PLC, it will not be the same for Allen Bradley PLC. 80% of the things will be the same. The basic environment will be the same. The basic pedagogies will be the same. But there are terminological difference. So this terminological jargon you have to play while you are working with a PLC, you are programming a PLC. Now you can see that input output channels, they provide isolation and signal conditioning functions. Now this is very important. There should be proper isolation and signal conditioning function when we are talking of direct connection of external sensors, switches, or some external actuator to the PLC. Because you know that unless you have proper isolation, then if there is some problem in the input channel, suppose a switch which is connected to typically a 10 volt system, but it is part, this 10 volt is part of a very big industry electrical network. So if there is some surge of voltage coming through the switch accidentally, then the switch will be burnt, and at the same time you are connecting the switch directly to the input port of the PLC, that will also be burnt. So your PLC will be damaged, your entire input card will be damaged for the PLC, which will cost you a lot. Therefore, already safety measures have been taken inside the PLC in form of isolations, and after that you are allowed to connect your device to the PLC. So whenever you have a PLC in your hand, you need not to know actually what is there inside as an isolator, because isolators are already provided. Here you are only going through it. आपको वहां पे बाहर से isolator लगा के कुछ भी नहीं लगाना है, be sure. But now you see that whenever we are talking of an output system, if you want to drive a very big motor with a PLC, then you need to have drivers for that, because PLCs are not able to supply very large amount of voltage or very large amount of current. So there you need to have already there is a driver interface, drivers are there like relays. But if suppose the particular relay that is connected to the output port of a PLC, because output signals are not directly given, because output signals are coming from CPUs. So what is the maximum current that a microprocessor can give at its one of the port? If you have already conducted practicals in your graduation days, you might have seen that even we do not connect an LED directly to a microprocessor output. we put an 8255 to the port, that programmable peripheral interface. Then we use a driver or we use a transistor as a driver to drive a certain LED. So the microprocessor, they can maximum I think they can source up to 10 milliampere. Now you cannot afford to run any motor, any LED, any hooter, any pilot lamp with the help of this 10 milliampere current signal. Therefore the driver interface is there, and always the outputs are connected to some driver. Output terminal from the CPU is connected to some driver. That driver can be a relay, can be a triac, like that. And after that the output channels are available to you for your interface. Now such type of things, whenever you are using, you must be very sure, that what is the maximum voltage and current that you can get out of the PLC. Or it may so happen that the PLC can give at the most 24 volt DC, and you are connecting, and maybe 2 ampere current, and you are connecting there a device which is 120 volt DC operation with a current requirement of 10 amperes, or it may be 24 volt with a current requirement of 10 amperes. Under that circumstances, it might burden the output PLC card and it may destroy that. So therefore be very sure about the capacity of the PLC before you are connecting any input or output devices. Now you see that there is a buffer thing. Why this buffer is there and why this latch is there, you have already gone through your courses in your undergraduation, that I will not talk about, because under that such situation I will not be able to complete the syllabus. But if you have got any particular problem about this, you can let me know. I will let you know the things about out of the lecture thing. Now see, sensors and actuators can be directly connected to them, okay, without the need of other circuitry, because already optoisolators and relays are there. Unless some specific requirement is there, be very sure about that. मैं ऐसा कहीं पे भी नहीं बोल रहा हूं कि आप डायरेक्टली लगा दीजिए. लगाने से पहले देख लीजिए कि जो वो इनपुट ले सकता है वही आप दे रहे हैं ना. अगर समझिए it can take maximum 5 volt as an input signal and you are trying to put 240 volt AC. Earlier it was 5 volt DC, you are trying to put 240 volt DC, so AC, then definitely your input card will be destroyed. So you need to be very sure about that. These are the practical aspects I am telling you, because there is no goodness of getting good in the theory of PLC unless you can work with it. There is no goodness. Once you go to the industry, PLC कैसा होता है, क्या होता है, ये जान के फायदा नहीं है. आप उसमें क्या कर सकते हैं, ये important है. So I am talking of these practical aspects. Please keep them noted. Now we are particularly talking of the input voltage. The digital signal that is compatible with the microprocessor in the PLC is 5 volt DC, that we have already seen. However, signal conditioning is there in the input channel with isolation. Isolation is very important. We will see how this isolation is achieved, and they enable a wide range of input signals that can be supplied to it. It can be a 5 volt signal, it can be a 24 volt signal, it can be a 110 volt signal, or it can be a 240 volt signal, it can be AC, it can be DC, depending on the certification by the manufacturer, how the manufacturer has provided it, how the manufacturer has provided the isolations or the signal conditioning inside it. That will ultimately decide that what level of voltage or current that device will be able to take in it. So be very sure about that. Without getting into manufacturer's details, do not work with a PLC. ऐसा हो सकता है कि आप लैब में जाएंगे, आपकी मैनुअल देखेंगे, मैनुअल में आपके एक्सपेरिमेंट दिया हुआ रहेगा, आप तुरंत स्टार्ट कर देंगे. अगर ऐसा करोगे तो आप बहुत गलत करोगे. पहला जरूरत है कि जो पीएलसी है उसके नंबर देखो, उसके नीचे क्या नंबर दिया हुआ है. उस नंबर देखने के बाद उस मैन्युफैक्चरर की वेबसाइट में जाओ, उसकी मैनुअल डाउनलोड करो, वो नंबर की पीएलसी के बारे में जो जो लिखा हुआ है उसको पढ़ने की कोशिश करो. मैं लिख के देता हूँ, 80% चीज आप समझ में नहीं आएगा आपको, बट 20% तो समझ में आएगा, वो जरूरी है. और धीरे 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 ये 80% में से कितना आपको समझ में आता है, ये आपको करनी पड़ेगी कोशिश. ये कोशिश करेंगे ना तो मुझे लेक्चर लेने की कोई जरूरत नहीं है, इतना ध्यान में रखिए. Now the input can be ready for digital signals or discrete signals. No, in most of the cases they are ready for discrete signal and digital signal. I am talking of only digital inputs. There can be analog inputs also, right? A small PLC is likely to have just one form of unit, that is 24 volt. ये सब जो है लार्जर पीएलसी जो है मॉड्यूलर पीएलसी में आप कर सकते हो. 5 वोल्ट, 24 वोल्ट, 110 वोल्ट, 240 वोल्ट, अलग अलग टाइप के इनपुट मॉड्यूल्स लगा सकते हो। तो जब छोटे पीएलसी की बात करेंगे जहाँ पे मॉड्यूल लगाने की कोई तरकीब नहीं है, वहाँ पे आपकी लगभग आपको एक ही वोल्टेज लेके काम करना पड़ता है, एंड दैट इज 24 वोल्ट, दैट इज अ स्टैंडर्ड। अब इसीलिए क्या होता है ना कि जितने भी इंडस्ट्री के लगने वाले सेंसर्स वगैरह बनते हैं ना, दे हैव ए वाइड ऑपरेशन रेंज, दे कैन ऑपरेट राइट फ्रॉम 9 वोल्ट टू 36 वोल्ट, क्योंकि पीएलसी छोड़ के भी दूसरा ऑपरेशन आ सकता है जहाँ पे ज़्यादा वोल्टेज की ज़रूरत है, या आप कोई लो सिग्नल डिवाइस के साथ आपके सेंसर को जोड़ना चाहते हो। ऐसे में अगर सिर्फ 24 वोल्ट वाले सेंसर ही मार्केट में निकलेंगे तो उनकी एक्सेप्टेबिलिटी कस्टमर में कम हो जाएगी, कस्टमर एंड पे। सो देयरफॉर मोस्ट ऑफ द सेंसर्स that are industrial sensors I am talking about, that are commercially available, that are having very wide voltage range, right from 9 volt to 36 volts, I feel. So I will stop here for this lecture and I will continue with the output unit in the next lecture. Thank you.